we have one last example. This is the last page, page 10 of lecture 17. This is the last page in the notes, and it's an application of what we've been doing. Okay, so we have the rabbit population is following a certain model, and T is the time in months since the beginning of the year. We'd like to draw a graph of what the population is doing. Okay, so what do? We look for the basic features just like we've done before. Okay, don't let the T throw you off. We're still applying the same ideas. Okay, so let's look at this. What is the domain? T can't be -1, but we're talking about time. So T is greater than 0 anyway. So notice we're not going to have a vertical asymptote in that domain region. This function is defined for all T in that domain. Okay, so no asymptotes, no vertical asymptotes, no holes in the function. Okay, because the only break would be at -1, which is not in the domain. Okay, what about a horizontal asymptote? Okay, we apply our rule. The numerator and denominator have same degree, so it will be where P is equal to 3,000 over 1, or 3,000. Remember, instead of y, we're using P for population. So we have a horizontal asymptote is P equals 3,000. Okay? And then we have our intercepts. And I think you can see that the only intercept we have is going to be at the origin. At time t equals 0, we're assuming the population is 0. So he has no rabbits. He starts counting when the first ones come. Okay? So let's see. Notice that if we think of our number line, there's really nothing to break it up because we're starting at 0. So we can choose any number in between, or after 0, plug it in. P of 1 is going to be what? 3,000 over 1 plus 1, which is 1,500. Notice that it's positive. So the graph is going to lie above the axis over the entire domain. All right? So to graph it, we simply have one really defining feature, and that is we have a horizontal asymptote. Okay? It starts at 0, 0. It lies above, so it's got to be doing something like this. Okay? Now here's where the calculus would really help to get a better picture, but this is a good idea, a good enough graph to be able to answer the second question. What eventually happens to the rabbit population? We see that it grows and grows. At what was it? At 1 hour we were up at 1,500. Okay, whoops, well, you get the idea. After 1 month, so we're at 1,500, and it's growing from there. But notice that the growth kind of slows down eventually, because it gets closer and closer to 3,000, but it doesn't quite hit it. So we see rapid growth in the beginning, slowing down towards the end. And so what eventually happens to the rabbit population? It approaches, but does not reach 3,000. And we would say that 3,000 is an upper bound of that population. Does that make sense? It's an upper bound because it gets closer and closer to it, but it doesn't hit it. Okay, that's lecture 7, and I hope this helps, and I hope it lets you see that you can graph very nicely and you don't have to be really intimidated. Okay, so thank you, and we're done.